figure out the action and how we. Okay, let's recap. We have defined our EM field for the 4 potential. Okay, so it is A0 and the vector A. So what is that equal to? Phi and vector A. So this implies this A here. Okay, so this is our field that represents the electromagnetic field, and the action we have written yesterday. So, yes. Any question? So the action, what we have arrived at? So we have the action of a particle, simple the free particle. So this is a relative free particle action, and then we are having an action that gives us the coupling of the particle with the field. Okay. Like this. Clear? So these are the 2 parts of the action we have done yesterday. So let's rewrite it. So along certain model line, let's rewrite it this way. So it is mc square root of 1 minus v square by c square v to the first object. Yes. So this is the action for, so it is this very term which we have derived in detail in last lecture. Okay. Now what about this thing? Let's rewrite it. It's E by C, okay, A mu. So I can write it like this thing, A0 Vx0 plus AI Vxi, where there is a summation over I. Okay. So there is a summation over I. So this is equal to minus E by C. So what is A0? A0 is phi. What is Vx0? C dt. So it is simply C phi dt. Okay. What's AI? AI is simply minus A. So AI dx is actually A dot dx, is it? So it will be minus A dot dx. Okay. So it is this very term. Let me write it. So that's equal to minus E by C. Okay, so this very term goes like this thing. Integral. Okay, now this I can write C phi dt minus vector A dx I can put as d dt. So if I have to write, let's say, the velocity, free velocity of the particle. So this is the free velocity. I can write it in this fashion. So I write this very. So this is what we have done in the last lecture. Okay. So what is our total action now? Yes. So you got it? Huh? This is what we have done yesterday, is it? We have done only till this very point. So let me rewrite it. So our action is equal to. So it is the action of a particle just coupled to an electromagnetic field. We are not considering the electromagnetic field part. Okay? We are not considering the action for electromagnetic field itself. Okay? So that we will do it later on. So this I can write it in this fashion. Minus mc square root of 1 minus v square by c square. Okay, then you put minus, okay, so it's plus E by C, okay, A dot V or V dot A, then you are having minus E phi, okay, dt. So this is the Lagrangian, okay, so this is equal to integral L dt. So what is our Lagrangian? X equal to minus mc square root of 1 minus v square and c square plus E by C A dot V. So this is the Lagrangian for a particle coupled to an electromagnetic field. Okay. So this is the free part. So this is the free part of the Lagrangian, and this is the coupling to the. So this is coupling with the electric field or rather with the scalar potential, and this is coupling with what? Vector potential. So entirely this represents the electromagnetic field. Clear? समझ आओ? So now once we have arrived at the action for a particle, okay, then we need to figure out the equations of motion. Okay. So once I know the equations of motion, then I can calculate the various physical quantities from the equation of motion. Okay. Clear? So there are two ways to derive, rather they are one and the same, but one is top bottom approach, and another is bottom top approach. Okay. So it's something like if you know the Euler-Lagrange equation, what is the form of Euler-Lagrange equation, and you know the Lagrange, and you calculate the equation of motion from Euler-Lagrange equation, is it? If you don't know the Euler-Lagrange equation directly, you know simply the action. You make a use of variational principle. From variational principle, you will arrive at equation of motion. It's one and the same thing. From the variational principle, you will get actually Euler-Lagrange equation, is it? Okay, from Euler-Lagrange equation, you are getting the equation of motion for a relevant Lagrangian, is it? But we will consider the action because we know, okay, so we know action for a particle, okay? So we can start just make use of this variational principle and calculate what are the equations of motion, okay? Or you can equivalently just use the equation, okay, Euler-Lagrange equation to calculate from here. We'll do it both ways, okay? Let's start from, let's do first the complicated one. So you are having action is equal to minus mc integral ds. So this integration along a world line, okay, between 2 points, and we'll consider the endpoints of the trajectory fixed, okay? We'll keep endpoints fixed. So that means if I am, let's say, moving from point A to point B, so, okay, and the trajectory is defined by this x mu of tau, there is no variation at point B, let's say, variation of x at point B, that's equal to 0, and variation of x at point A, that's equal to 0. So it means we'll be using endpoints, the fixed endpoints. Okay, so it's simply u mu v of delta x mu. Okay, so this is our first term. Is it? Right? Any problem? Minus e by c, then what we are having? Let me write this very term first. So a mu d of delta x mu, okay, minus e by c, variation mu. Okay, so this is our variation s. Now look here, so you are having this variation of x within this d, is it? So that means I need to integrate this by parts, okay, so that I can apply the boundary conditions. This variation, our endpoints are fixed, and similarly here you are having this objective within this d, okay. So now I can integrate by parts this very term and integrate by parts this term, okay. Got it? Let's integrate these two terms by parts, then we can appreciate actually what I am saying. Okay, so let's take integrating by parts. Okay, first term, first and second term. In equation, let's see, 4. So what is that? So I am having this very integral minus mc u mu d of variation in x mu. So let's integrate this by parts. So first term will be as such, minus mc u mu, okay. So this will be simply variation in x mu evaluated at the points E and D, okay. Then you are having the second term minus, since minus is already here, it will become plus. So it's integral mc, so it is du mu by ds, because we are integrating along the word line, okay. So what this will be? This will be simply delta x. Okay, what about this objective? So this objective goes to 0 at endpoints. So this is simply mc integral du by ds and delta x. Clear? Yes. Anybody? Now tell me. So this is the first term and this is the second term. Integrated parts. Huh? Integrated parts. So it will be variation of, okay, so total variation of A mu, then the delta x. Is it? Clear? Is it clear? So it will be simply, you need to write the total variation. Huh? Okay? Any question? Okay, so this object goes to 0 at the endpoints. Now let's substitute back these results here. Okay. So let's write. So it is integral. So this term becomes mc du mu by ds, and then you are having dx mu. Clear? Then you are having from this very term as plus e by c dA mu. Then you are having delta x mu. Okay? Then you are having this very term minus e by c delta of A mu, and then you are having. So this is the variation in action. Okay? Now let's move a little bit. Okay, look at this these two terms. This very thing. So this is actually the total variation of A, is it? A is in general the function of coordinates. Clear? So A can be function of both x and t. So you need to figure out what is the total variation of A, is it? And this is also the variation in A. Okay? So I need to figure out what exactly these variations are. Samajh? Okay. Now tell me, let's say if I am having f is a function, okay? So if I write this gf, how I can put it? Total variation. Let's say if it is the function of x, simply f of x, so you can write partial f by partial x and then dx. So this is very important point, so you put it as a dx. Now if I am having the same thing, delta f of x, how you put it as? Same, partial f by partial x, but here it will be as delta x. Okay? Clear? So now, since I am considering only one variable here, so you put it this way. So this A mu is actually in general. So you are having A mu as function of, let's say, x and t, is it? So x vector or r, you can say. So all the four coordinates are there, is it? Clear? So once I write now, okay, let's write. This dA mu. Let's write. So how it will be? Can anybody? So it will be some partial A mu by partial x. Is it? What I will put? Let's say A mu, partial x mu, and then what it will be here? Dx mu. So this index is contracted. So it will be actually in this fashion. You can write it, let's say, partial A mu by, let's assume, partial t dt plus partial A mu by, let's say, partial x dx plus so on. Clear? So it will be of this form. So I have put it in this fashion because you put actually a summation convention on this index mu. Okay? So summation, because I am having only four coordinates here, 0 and 0, 1, 2, 3. Okay, so this mu goes from 0 to 3. Okay, so you are having four terms in this expression. Clear? Samajh? Okay. Now similarly, I can have this variation in A mu. So how I can put it as? Partial A mu by partial, let's say, x alpha variation in x alpha. Let's write mu for the time being. And let's write same thing with mathematics. Clear? So this will be simply variation of A with respect to all the coordinates multiplied by the variations. Is it? Okay, let's substitute. So therefore, I can write this variation in S as integral mc du mu by ds dx mu. So it's E by C dA mu. Tell me what is dA mu? Partial A mu by partial x mu. So dx mu. Then what you are having? This delta x mu. Okay. So look here. So you are having this mu and mu contracted, and this new contracted. Then another term is E by C. So it is partial A mu by partial x nu, variation in x nu, and then you are having this gx. Is it? Is that true? So you are having variation in x here. So this new, okay. I have put the indices same. These two terms are in addition. Okay. So that is why you put dim index, the same dim index here, nu and nu, mu and nu. If they were in the multiplication, then you choose a different dim index. Okay. In addition, it doesn't matter. Huh? Okay. Now let's do this way. Now look here. So you are having partial A mu by partial x nu, dx nu, delta of x nu, is it? So I want to bring this term in the same form. So it is variation of x mu, and you are having variation in x nu, is it? And you are having gx mu and dx nu. I want to make these two terms same. Okay, so these coefficients, because they are linearly independent. Okay, so how to do it? So what I can do in this very term, okay, I interchange dim indices. Interchange mu and nu. What does that mean? So can I interchange dim indices? It's okay, it's normal. Huh? Okay, good. So how it looks like then? So once you change mu and nu, this term will look like this way. Partial A nu by partial x mu, okay, delta of x mu and d of x nu. Is it? This is again the same term. Okay, so you can put, let's say I, okay, I, j, j, is it? Then you put I as nu and j as mu. Okay, clear? Samajha? Okay, good. So let's rewrite it. So therefore, this variation in S, it is equal to MC du mu by ds dx mu, okay, plus E by C, okay, partial A mu by partial x mu. Okay, since E by C is common, I will put E by C common. Now which factor appears common? This delta x mu and dx nu. So it's common, so I will take it out. So minus partial A mu by partial x mu. Partial A nu by partial x mu multiplied by variation in x mu dx. Okay, and this action has to be equal to by definition. So what was the first term? So you are having u mu, then d of delta x mu, is it? So this was the term with minus MC out. Is it true? So let's forget about this MC. So when I integrate this by parts, it's u mu. Because, okay, although we are integrating along the word line, is it? But it is just a differential here. Is that true? Is it clear? So how I can write it? So I can simply put it as delta x mu, okay, evaluated at where? A and B, okay, minus. So this differential will get shifted here. So it is simply d mu delta of x mu. Clear? So if I put, let's say, ds here along the word line, then I need to put a ds here. So it is like this thing. So it will be simply ds multiplied by ds. Clear? So we have forgot actually a factor of what? ds. Clear? So okay. So that's why there is an error. Okay. So you can write ds. Samajha? Oh, wait a second. It will be simply not delta, huh? Because we are differentiating this, huh? It is delta x. So this is delta x. Delta. Just take. Clear? So everybody followed it what I have done here? You are having u mu d of delta of x mu, is it? I am integrating. Okay, so this d will go. So we will be having simply delta x mu. I actually had written what d. So it is not d. It is actually delta. Huh? So this was the error I was looking for. Huh? Okay. So now let's write, okay, look here. So you are having delta x mu here, is it? Is it clear? So you are having delta x mu here. What additional is here? Dx here. Okay, can I raise this mu up and lower down this? Can I raise? Or in other words, I can do the other way. Yeah? So you raise this index up and lower down this index. True? Can I do it? Okay. So now let's write this dx mu. Okay, this dx mu. So we are having the 4 velocity u mu. We simply write it as dx mu by ds. Is it? So what it gives me? Dx mu is equal to what? U mu ds. Is that true? So this is how I can write now this line element in the four-dimensional form. So I can put simply the 4 velocity multiplied by the this proper length. Is it? Or the proper time? Huh? Clear? Yes. So now this I can put this dx nu as u nu multiplied by ds. Clear? Therefore I can write this minus, okay, sorry, mc du mu by ds. Okay, delta x mu ds. Let me put it this way. Okay, then anybody? Just plus E by C. Okay, partial A mu by partial x mu minus partial A mu by partial x mu, because okay, so this is the only difficult equation we are deriving. Rest will be easy. Okay, so then you are having this delta x mu, and for this dx nu I will put as u nu ds. Okay, and this object is equal to 0. True? So what I can do, okay, so let's raise this index mu up, so I have to then lower this down, is it? Because mu is an index which is contracted. So in in contraction, you can the upper you can lower, and lower you can raise, is it? Similarly, this nu I can. Am I saying correct things? Yes. So look here. It is a tricky thing. So this I can put, look here, partial mu A mu. So I will write multiplied by delta x mu. Okay, for you people, no? Just to understand it. So this mu is a lower index. So I will put it this way: partial mu. Okay, this is a lower index. I will put it in this fashion. This mu I will lower down, delta x mu and u mu. Is it true? Is it okay? Can I do it? Can I do it first? Everybody? Okay. Okay, now let's take this one, this very term. So it's partial mu A nu multiplied by this delta x mu u nu. So how you can put it as partial mu up and A nu up. Okay, then you have this delta x mu and u nu. Clear? Clear? True? Can I do it? Can I do it? First tell me. Can I do it? Okay, good. So if I can do it, then I can write it in this fashion. Okay? Now look here. So you are having this delta x mu sitting outside and ds, is it? So what you are having? Delta x mu here and ds, is it? So I can take them common. So I can write it in this fashion: mc du mu by ds, okay, plus E by C, okay. This I can write as, okay, partial A mu. So mu I am raising, and I have also this nu. If you see, nu is raised, is it? So if nu is raised, then it will go down, is it? Like this way, Isha? Minus partial A nu by partial x mu this way. Okay, then you are having u nu. Okay, then you are having this delta x mu ds, that's equal to 0. So when this integral is equal to 0, so these are non-zeros. Okay, so it means this objective has to be equal to what? So it means, so from delta s equal to 0, we get equation of motion as mc du mu by ds. Okay, so that's equal to, okay, I will write it in this fashion, E by C. I will write first term, okay, second term first. So it's partial A nu by partial x mu, sorry, x mu minus partial A mu by partial x mu. Then you are having u mu. Okay? True? Is it clear? So this is the Lorentz force equation in 4-dimensional form. Okay? So we call this object, this elephant we call, okay, we write this as F mu nu. So that's equal to partial A nu by partial x mu minus, sorry, partial A mu by partial x mu. So or in short form this way, partial mu A nu, you remember it this way, partial mu A. So this is known as electromagnetic field density. We'll see why it is known as electromagnetic field density. Okay? Clear? So now let's write it. Therefore, I have mc du by ds is equal to E by C F mu nu. Oh, look how nice this equation is, yeah? Okay? So it's a monster, huh? No, it's very beautiful equation. Huh? So this is Lorentz force equation in 4-dimensional form or in a coherent form. F mu nu is known as electromagnetic field tensor. Now let's look at this F mu nu, what this object is. Okay? Okay, can anyone tell me what is the rank of this F mu nu? 2, is it? So it's a rank 2 tensor. Now we need to figure out what kind of tensor it is. Okay? Whether it is symmetric tensor or antisymmetric tensor. If it is symmetric, then I can figure out the components. If it's antisymmetric, I can again find out. Okay, now let's first figure out what it is. So if I write, okay, so we are having this F mu nu as partial mu A mu minus partial mu A, sorry, partial mu A nu and partial mu A. Okay, so let's interchange the indices. Okay. So let me take this minus out. What it gives me? Partial mu A mu minus partial mu A nu. Is it clear? So I will just take a minus sign out. I will get this object. Is it? So what it is? Minus. So this I can write F mu mu. Can I write it? Just starting from the definition. That means this is actually F mu mu. What it gives me? So I am interchanging the two indices mu and mu. What I get? A negative sign, is it? So that means it is rank 2 antisymmetric tensor. So when you are having antisymmetric, okay, let's say if you are having an antisymmetric matrix, what are its diagonal elements? 0, yes. So that means the diagonal terms of this rank 2 tensor, sorry, this antisymmetric rank 2 tensor are 0. Clear? So much, Shaman? Okay, now tell me what is the dimension of this F mu nu? I mean, what dimension matrix it corresponds to? I told you last time rank 2 tensors we can represent by matrices, is it? So what is the dimension of this matrix? Okay, tell me what is the range of mu? 0 to 3. What is the range of nu? 0 to 3, is it? So how many dimensions it will yield? 4 by 4. So it will be a 4-dimensional matrix, a square matrix, 4-dimensional. Okay, so in this 4-dimensional matrix, okay, so I can put this F mu nu in terms of what? A 4-dimensional matrix, is it? So what are the diagonal terms? So diagonal terms are 0. Okay, so because of this thing, that's calculated from here. So we are having, if you are having F mu nu is equal to minus f mu mu. Okay, so therefore I can write, let's say f00. So 0 0 component. So you can write this as, let's say 0 0 1 2 and 3 1 2 and 3. Okay, so 0 0 component 1 1 2 2 and 3 3. Okay, so this will be minus f00. What is that equal to? It is only possible when f00 is 0. Similarly, if I take f11, that's equal to minus f11. So just substitute here. So it implies what? f11 it is equal to 0 and so on. So that means the diagonal terms of this matrix are 0. Now tell me how many independent elements it will be having. So you are having a 4 by 4 matrix. Let's say 4 by 4 real matrix you are having. How many independent entries there are? First, tell me. So you are having a 4 by 4 matrix. How many entries are there? 6 terms. Now I am saying it is an antisymmetric matrix. So what it will yield in me? How many now independent terms will be there? Or entries? Okay, diagonal terms are 0. Out of 16, you remove what? 4. Okay? So how many are remaining? 12. But if you see, when you are saying antisymmetric, that means the elements here are the same here, just as a sign change. So now count the elements here. How they are? Just 6. Is it? So that means I will be having only 6 linearly independent terms for this f mu nu. Okay, I am saying it's a field electromagnetic field tensor. It represents simply electromagnetic field. Now tell me how I represent the electromagnetic field? By electric field and magnetic field, is it? So how many components are there? 6. So those are linearly independent, and those independent terms will appear in this matrix. Okay? So let's check it. Let's show it. Okay. So let's take these elements. So what this will be? It's actually, okay, so this was F00, this will be F01, F02 and F03. What they will be? So this will be F10, F20, F30, let's say. So if I know this thing, I will know, because they are just, there is a sign change only. Now let's write this F01. Okay? So let's put it in the formula. So it will be simply partial 0 A1 minus partial 1 A 0. Okay. Now what is partial 0? Okay, it's partial. Okay. Can anyone tell me what is partial 0? It's 1 by C partial by partial D. What is A1? It's simply AX, is it? So let me write it this way. So you are having this A mu as phi, then AX, AY, AZ, is it? So that's equal to A0, A1, A2 and A3. Just for you people, I am writing it again. So what this is? Phi. So it will be minus AX minus AY minus AZ. What is that equal to? Phi, A1, A2 and A3. Okay? So what is this partial 1? Can anybody? So I wrote last time partial nu as 1 by C partial by partial T and gradient, is it? And this partial mu, when you are having upper, so it's like this thing. So this was the notation we are using, is it? So now you are having this partial 1, is it? This is 1 is upper. So it will be simply minus time minus simple partial by partial x. So if I calculate partial 1, so it is what? Partial by partial x with a minus sign here. A0 is simply phi. So what is that equal? Let's put this here. So it's partial by partial x phi. Okay? That's my third one. That's my third one. Oh no, it's corrected. Plus 1 by C partial AX by partial D. Is it? Can you tell me what this is? If I can write minus outside, minus partial phi by partial x, minus 1 by c partial ax by partial t. Can you tell me what this is? So this is the electric field along x direction, is it? So what is the electric field? Minus gradient of phi minus 1 by c partial a by partial t. Is that true? So this is how we define the electric field, okay? So this is simply as minus Ex. So F01 is minus Ex. Similarly, you can write, okay, let's write F02, that's minus Ey, and F03 is minus Ex. Okay? So now tell me what I get. So I am having F10 as simply as Ex, F20 as simply as Ey, and F30 as Ez. Clear? Everybody followed it? Huh? Everybody? So that means the components of F, which is having one as temporal index, another as spatial index, they are simply the electric fields. Or in other words, this object F0i or Fi0, that's equal to minus F0i, that is equal to the components of the electric field, while I is equal to 1. So it means for this very matrix, the upper row and the first column, so they simply represent the electric fields. Okay? Samashaman? So we have identified 3 components of F. Now we need to figure out how many? 3. The other 3. Okay? So let's try to figure them out. Okay, so we are having now F mu. So this is the object we'll be using. Yes, any question? Yes? So this is our formula. Any question? Huh? So we have figured out 0, 0 elements, 0, 0, 1, 1, 2, 2 and 3, 3. These elements, these are 0, and we have figured out 0, 1, 0, 2, 0, is it? That means while you are having one temporal index, another as spatial index. Now what we need to figure out? While you are having both spatial indices, is it? So you are having spatial index here. Let's say F, what it is? 1 and okay, F12, F13 and F23, is it? So these are the elements. So we need to figure out those components which are having for F, which is having what? Both mu and nu are spatial. Okay? Space 1, 2, 3. Okay, this is special. Okay, so let's write. Let's take this object F12. Okay, let's first calculate this way. Let's write F1. So I am writing it as partial 1 A2 minus partial 2 A1. Okay, clear? So now tell me what is this partial 1? Can you tell me? What is partial 1? You are look at the bottom, partial nu upper. So it's a minus, is it? So it will be minus partial by partial x, is it? What is this A2? A2 is simply A1. Clear? Is that true? Now minus, what is partial 2? It's minus partial by partial y. What is A1? It's simply AX. Clear? So can I write it in this fashion? Minus I will take out partial AY by partial x minus partial AX by partial y. Can anybody tell me what this object is? It is which component? It's actually the Z component of del cross A, is it? Okay, now let me write. So you are having this object del cross A. Let's write its components. So let's write ith component. Partial AZ minus partial AY by partial Z. So this is the x component. Then what is another thing? Another term? Partial So it will be y will be partial z y minus partial by partial y a z y component, then partial by. So go in the cycle term, partial x by partial a y minus partial x by partial. So this is the z component, is it?
Or second
Huh?
partial az by partial x.
Where?
Second y component.
So y x. Yes. Huh? Clear? So this is how you just evaluate. Okay. What my point is, now look here. So you are having this object. What this represents? It represents me the z component of del cross A. Now what is del cross A? Is magnetic field. So this object will be simply, so you are having minus here, so this will be simply dz. Okay? So that means F12 represents the minus dz. Samajh aaya? Similarly, now let's calculate this F3. Okay? Let's calculate this object in a cyclic fashion. Let's calculate. So now tell me what that will be. Partial 2 A3 minus partial 3 A2. So what is that? So minus partial by partial y A3 will be simply AZ minus partial by partial Z A. So AY. So what is that equal to? So it's minus dx. Okay, another will be actually plus when you are having 1 3 here. So when you write 1 3, so let's write it as partial 1 by partial 1 A3 minus partial 3 A1. So what is that equal to? Minus partial by partial x AZ minus partial by partial Z AX. So there is actually a sign change. Sorry, it is plus. So it is partial AZ. So it is simply B1. Okay. So you take minus here. So simply B1. So two are negative. Another one is what? Positive. Shall I write now this matrix? F mu. Shall I write? So let's write. So our matrix F mu, that's so start with 0, then you are having minus EX, minus EY, and minus EZ. Okay, then you are having EX here, EY here, and EZ here. Then you are having 0, then what you are having? Minus BZ, then you are having, okay, BY. Okay, what it is? So it will be BZ, it is 0. What this will be? What this is? So it is BX minus. So what this will be? Minus BY, then you are having BX here. So this is your F mu. Now look here, you are having, it contains the components of the electric and magnetic field vectors. Okay? That's why we call it as an electromagnetic field tensor. Okay. Similarly, okay. Now let's write this F mu nu. Can you tell me what this will be? Tell me F mu nu. What is F mu nu? Now you are having both lower indices, is it? Some of your diagonal terms will be what? 0. Let's take the first diagonal term 0. Now what about this very objective? So you are having one temporal index, one special index, is it? So that means okay, so it is actually this way, F01. So I have come from like this thing, F01 to F01, is it? I am lowering down one temporal index, one special index. So lowering down temporal index does not yield a sign change, is it? So lowering down special index yields me what? A sign change. So that means this will be what? Plus EX, and this will be what? Plus EY, then plus EZ. What this will be? Minus, okay? Minus EY, minus E, okay? Minus EZ. Clear? So then this term is 0. Now tell me what about this thing? So here both are special index, is it? So it is what? F F12, is it? So once you lower down F12, you lower down 1, then the another special index. First index will yield a sign change, another will also, then it will be no sign change, is it? So it will be again here what? Minus Bz, By. So these will remain unchanged. Only these temporal terms will be what? Changed. They will yield me a sign change. Okay? So this is your okay? समझ आवा? Okay. So now let's arrive at our favorite equation. Okay, yes, one more point. So this will be last. What's our this B? Let's write B vector as curl of A, is it? Can I write it? Let's write its ith component. Now tell me what is that? So it is the ith component of this object. So let's put it in the tensorial notation. So it's epsilon I j k. So it is partial j a k. Is that true? Is it true? So what's your? Now look here. So now the rule we have actually done earlier. So this j and k index, if you see, so this if I interchange j and k, it's antisymmetric, is it? If you interchange any two indices on this epsilon, so it's an antisymmetric tensor, is it? So, but statistically, you are having j index here, k index here, and j here, k here, is it? So this is antisymmetric in j and k, is it? I know that. So if I multiply this quantity, any quantity, an arbitrary quantity, if I multiply with the antisymmetric or let's say it's symmetric, you need to do the same symmetrization procedure for this object. Clear? So much. If you remember, okay. So this object is a matrix. If you see, so it is having components j and k, is it? So now I can always decompose a given matrix in terms of symmetric and antisymmetric matrices. But we have done, if you are having symmetric multiplied by an antisymmetric thing, so that yields me a 0, is it? So there will be only what? What part? Antisymmetric part left. So it means if you are encountering any two indices to be antisymmetric, you know them to be antisymmetric. Another two indices you have to antisymmetrize. Let's assume if it happened to be symmetric in this case, then you need to symmetrize this very object, okay? To have the proper symmetry rule. So much so that the entire quantity is having that property. What I mean by that, I will try to antisymmetrize it. So epsilon I j k. Now let's put it in the antisymmetric form. It's partial j a k minus k a j. Is it? So then you divide it by 2 because you are having only two terms. Clear? So much. Now if you, let's say, interchange the terms here. So it will yield me what? A sign change. So it will be plus. So 2. So these will be simply 2 factors. Okay? So much. Okay. So it is half of epsilon I j k. Okay. So this I can write in this form, partial j a k, because these are only the special indices. J k minus partial k. Let's put it in this fashion. Now what this object is? Can you tell me? It is simply f j k. So j k, these are actually special indices. I goes from 1 to 3 and j k also goes from what? 1 to 3. They are special indices. So it means, so the magnetic field is related. Ith component of magnetic field is related to the special components of this. In other words, I actually constructed a dual vector to the rank 2 tensor, antisymmetric rank 2 tensor. So you can think this is dual vector to this very tensor. Okay? So now let's calculate fj in terms of b. Let's calculate. So let me multiply this epsilon. Here it is I. Okay? Let me multiply epsilon I L M B I like this way. It is half of epsilon I L M. You need to actually practice this object at your places, and you can appreciate the result. Okay? So I need to figure out what is f in terms of b. I have figured out b in terms of f. Is it? So you are multiplying this tensor. I want to get rid of this epsilon, and I want to take this epsilon here. Okay? so that I can express this f in terms of b. समझ आओ? So that's why I have put epsilon I lm. So I will contract only one index, another two are free in a sense, because I know the formula for this very object. You are having I here and I here, so they are contracted, is it? Now tell me what is the formula? So it is half here, so it will be delta Lj delta Mk minus delta Lk delta Mg. Okay? Fg. So this will yield you half a. So the first term is only non-zero when L is equal to J and M is equal to K. So I will keep J, okay. J I will put as L, K I will put as M, because there is a some more J and some more K. Minus, okay. So you are having K replaced by L, J replaced by M. So it is like this thing. Now I know this is antisymmetric in nature, so it is something FLM plus FL. So that's what F. So in other words, this, so therefore Fig can be written as epsilon. Let's write this way. Ig. Okay. So that means you can construct the special components of F from the vector B, or you can construct a B from the special components of F. Okay? So this is the relation between B and F. Any question till now? So I think let's stop here. So we'll be meeting tomorrow.